So chapter 5 is pretty quick, so we're just going to go over it really quickly. It is low-key a mix of what we've been doing before. So we're going to go reactions of alcohols, oxidation. So again, this should be a review if you've been paying attention. If you haven't, then go back. You're going to be confused. So oxidation reactions. So again, primary alcohol, aldehyde. Okay. And this is if you use a weak oxidizing agent, commonly PCC. Now, common is PCC, but again, like just in case you see another weak one. So we know that, I spoiled the answer. We know that OH, weak or strong. Weak or strong, a secondary OH will always make a ketone, okay? Now, if you have a primary with Jones or any other strong, you would get this group. Okay? So that's all you need to know for oxidation. At least that's all I see here. Nice. So, next, we need to go over methylates and tosates. Now, I'm going to draw the structure, but you don't really need to know it, but it's here. So first, I want to tell you the point of these. So I'm going to first, so this is MESYLATE. It looks something like this. Okay, by the way, this is CH3. So this is that, and then tosate looks like this. Okay, so that's how they look, but that's not really the point, right? So the point I'm trying to make here is alcohols are usually bad leaving groups, okay, right? So alcohols are bad leaving groups, right? Like we went over before, strong bases are bad leaving groups, okay? So usually an alcohol can't leave, but if you add any one of these two, it doesn't matter which one, okay? They both do the same thing. And it's usually abbreviated like this. So if you have OMS or you don't have to draw the structure every time. Make sure you recognize this part. OMS or OTS makes these guys a good leaving group, meaning you can now do SN1 and SN2 reactions with this, okay? So that's the whole point of these. We're going to make alcohols a better leaving group, and yeah. And they could also they can also be something called a protecting group, which we're going to go over now. So a protecting group is really any like dihydrogen, okay? Meaning like 1, 2. Like if you have 2 hydrogens on a thing, right? So the point of this is protecting groups stop other things from reacting, okay? And let me show you what I mean. So let's say that we have this, okay? And let's say we react, we react this. Oh, there's no benzene. Duh, you can't make 5 bonds. But we react this with okay, you would get an OH here and an OH here. But the question is, what if I don't want both of OH? What if I only want to make this one an OH? Well, you can use what we call a protecting group. So whenever these groups are added onto, also, you only add them onto aldehydes or ketones, okay? Do not add them onto anything else. It doesn't just add on to a carbonyl. It only adds on to aldehydes and ketones. Make sure you know that. So, and this, it looks a little funky, but it's fine. There is a mechanism, but you don't need to know it. Okay, so what that does is now this is where it matters. So now when we use LiAlH4, we can now only reduce the ester, and we keep this guy here. So I want to pause here for a second. Do you see how the difference between it is? See here versus here, right? This guy didn't turn into an alcohol due to the protecting group. So what we do is we then remove the protecting group by using H3O plus, which can also be written as H2O, comma H plus. And what that does is that removes your protecting group. So now I can get the molecule I want without having to react both. Isn't that cool? So yeah, so you see how much the protecting group did. So we went from 2 alcohols, right, to now just 1. You see, due to the protecting group, this top ketone didn't react. And just to answer a question that I already hear, no, you cannot turn esters into protecting groups. This doesn't exist, okay? You can only do it on aldehydes and ketones. You cannot just do it on any double bond carbon that you see. So that's it for reactions of aldehydes and ketones. So next we're going to do chapter 5.3, which is reactions of phenols. So I'll see you there.